Alright, so we're factoring each polynomial. It's important to recognize the type of polynomial that we are factoring. We have the first question. The first thing to always look for is the highest common factor in all the terms, whether it's 2, 3, or more terms involved. Comparing both terms in the first question, we see that we have common factors outside of the coefficients in x and y. So we look and compare the variables x in both terms. We will select the one with the lowest power as a common factor in both terms. We'll turn our attention to the y, and since they're both the same, we'll basically select y as a common factor of itself. We'll look at the coefficient, which is a constant. The coefficient themselves being constants, so the common factor of 3 and 5 is 1. So there's no need to take out 1. We'll insert brackets. I will need to multiply by 3 to get back the 3, because when I multiply them by distributive property, I should get back the term on top. 1 times 3 will give us back the 3. Well, we have a x squared, but we need x cubed, so we have to multiply by x to get back the x cubed. X squared times x will give us x cubed. We already have the y, so no need to multiply by that. Then put a plus sign. What times x squared y will give us 5x squared y? Well, we do not have the 5, so let's put that there, since 1 times 5 will give us 5 by distributive property. We already have an x squared, and we already have a y, so we stop right there. So that's basically it for that one. So the answer is going to be in bracket 3x plus 5 as a factor, and outside the bracket we have the 1x squared y. We don't need to put the 1 itself, we can actually take it out. But remember, another way to do this is to divide each term above, like for instance 3x cubed y, by a common factor of x squared y. The y's cancel, and we won't cancel the 3 because there's a 1 underneath, so that will still give us back the 3. We keep the base x, and 3 minus 2 is 1, so our answer there, the factor we'll have in bracket will be 3x. When we divide the same, using the same process, 5x squared, that's the other term, divided by the common factor, x squared y. Again, we can think of a 1 there. 5 divided by 1 is 5. The x squared will cancel out x squared. The y will cancel out y. By the way, they go into each other once, right? X squared into self goes once, y into self goes once. So we're just left with 5. And as you can see, that's what we put in the bracket. And when we look in the bracket, we can't factor any further, so this will be the answer. Number 2, look to see if we have a common factor in all. We can take out the negative for sure. 5 can actually enter all of them, right? Any number ending with 5 or 0, 5 can enter. So we can take out 5. What about a? Well, a squared is here, a is here, but there's no a in the last term, so that's not a common factor to all. Now, in the bracket, negative 5 times what will give us? Negative 5a squared. So all we need is a squared. Since negative 5 times a squared is negative 5a squared. Negative 5 times what will give us negative 35a? Well, that will be a positive, of course, since negative times positive is negative. 5 times 7 give us 35, but we needed a to give us a negative 35a. So that's negative times positive is negative, and 5 times 7a is 35a. Now negative times what will be negative? Again, it will be positive. And 5 times what will give us the 50? That's 5 times 10. So negative 5 times positive 10 give us negative 50. And then we can we factor what's in the bracket? Because we got one factor, which is negative 5. And we have another factor in the bracket, which is a quadratic expression, or quadratic trinomial. That quadratic has 2 pairs of factors. A times a give us a squared. 5 times 2 give us 10. And it's all positive, right? So the signs will be positive. So I know 5 times, well, a times a give me a squared. 5 times 2 gives me 10. So that's the first, to give me the first term here. The last 2, right? Let's call that the last, right? The last 2. 5 times 2 give us 10. And the in and outer should give me 7a. So 5 times a is 5a. A times 2 give me 2a. When we add them, we get 7a. Now, of course, we didn't have to go through all this if we keep in mind that as long as the first term, in this case the quadratic term, has a 1, right? As long as the quadratic term has a 1, coefficient is 1, then all we need to do is to find the factors of 10 that when multiplied give us 10, of course, obviously. So it has to be the pure factors, right? So we know 1 times 10 give us 10, and we know 2 times 5. But which one of these pairs will add, when added, give us 7? And that will be the 2 and the 5. So all we have to do then is just simply say a, since we're dealing with a's, right? A plus 2 and times a plus 5. Now this only works when the coefficient of the quadratic term is a 1. right? And that's what we have in brackets. So it doesn't matter the order. So we could have the a plus 5 first, then the a plus 2. Doesn't matter, because the order in which we multiply doesn't matter. Okay, so we didn't have to go through this process, but this process is good for when we're dealing with other quadratic expression where the coefficient of the quadratic term is greater than 1. All right, or we could say even less than 1 as well too, because you could have negative as well. All right, so let's look at this one now. When we have 4 terms, typically we look to see, it doesn't matter how many terms, we look to see if we have a common factor in all the terms. And let's see, x is not in the last one, and a is not in the first or second one, so definitely not. But typically when you have 4 terms, it's factorization by grouping. So we're going to look at the first 2 terms and pick out the common factor. I see x being common because they have x cubed and x, so I choose the lowest one, which will be common in itself, and also the higher one. The y will be in both, of course. Then insert brackets. Okay, x times what give me the x cube. I need x squared here, so when I multiply by x squared, I get x cubed. Since we already have a y, that satisfies that. I have xy. What do I multiply xy by to get 2xy? Must be 2. xy times 2 is 2xy. For me, I think it's much easier to do it like that. But if you want to do the division, that's okay. By dividing x cubed y by xy, x will cancel out x will cancel out one of the x from x cubed to give us x squared, and y will cancel y. So we only have x squared. And for the second term, 2xy divided by xy, xy will cancel out xy, leaving us with 2. All right, each his own. Some people may find that faster. Now, if you look at the last 2, a is common. It's all positive, by the way, so that should be easy to just realize it's a positive that will go here. In some cases, it might be minus, so you have to always check. Once you pull out the a, we're gonna left with what? What are we gonna be left with? So we're gonna left with x squared. So it's a times x squared is ax squared, and a times 2 will be 2a. All right. So now, if we look at both sections, if we look at this section and this section, what's common? The x squared plus 2. So we're going to take out that as the common factor. I'm going to take out the x squared as the common factor. X squared plus 2. Right, it's a binomial factor that's common to both sides. Then, since I take out the x squared plus 2, what am I left with? It's like dividing the xy times x squared plus 2 divided by the common factor of x squared plus 2. What will happen here? This will cancel this, leaving us with xy. Now I'm going to do the same thing with this one. I'm going to divide this by the common factor of this. And when I do that, the x squared plus 2 cancel out the x squared plus 2, leaving us with just the a. Alright, so a quick way to see this is that what's in the bracket will go in one bracket, and what's outside the bracket goes in another pair bracket. We have a trinomial here, no common factor in all 3 terms. So we go right ahead and factorize. 3 and 2 are factors of 6. So I'm going to use 3 and 2x. When multiply, give us 6x squared. 7 only has 7 and 1 as factors. So let's put the 7 here and the 1 here. For now, let's see if that works. 7 threes is 21. 2 times 1 is 2. That will not give us 21, and 2 will not work out to be 11 under any circumstance. So I'm going to try again. Let's try switching them around. So let's put the 7 here and the 1 here. Alright, 3 times 1 is 3, in this case 3x. 2 times 7 is 14x. 14x, definitely we can get 11. Now we'd have to subtract to get 11, right? And that makes sense though, because when the last term is negative, right, down here we'd have to use subtraction. So one has to be positive and one has to be negative, making the bigger one the positive and the smaller one the negative. We end up with 11x, positive 11x, which is what we're looking for. Right, the inner and outer should give us the positive 11x. So for the inner, this has to be positive. Inner, this has to be positive. Positive 7 times 2x will give a positive 14x. And 3x times negative 1 will give us what? Negative 3x. But why did they give the 14 the positive? Again, we wanted a positive 11x. So it's always safer to give the bigger quantity, in this case 14x, the sign of the middle term. Alright, so if we had a negative 11, then we would have given the negative to the 14 and the positive to the 3x. Alright, hope that is clear. So that's the answer, guys. 3x plus 7 as one quantity, the next 2x minus 1. Okay, so we're looking at the other one. Let's see what's common in all. We have 25 here, and for the n, no common factor but 1. But 25 is a perfect square, and so is 4. So I'm deeming this to be probably a perfect square. Let's see. If I should square that, I do get 25x squared. And I have a negative 20 there. So I'm assuming that this should be a negative number here. So maybe negative 2 to be squared. And that being said, then it should be a positive 2 times the first, which would be 5x, times the last, which would be negative 2. Let's put a plus there. If we work this out, we'll actually get what's on top. So this is really a perfect square. So we'd have a 5x in one and negative 2 in the other. Right? So as long as it's in this form, by the way, a squared plus 2ab plus b squared. I think that's the form we're really looking for, which I just did a while ago. Okay, once it's in the form, you can write it as this: a plus b all squared. Now if you don't get that, then we could simply do it the longer way. Number 5, alternatively, we could use the same concept we've been using. 2 pairs of brackets. Well, 5x times 5x will give us what? 25x squared. Since the last term is positive, both signs have to be the same. I look in the middle and it's negative, so they have to be negatively the same. Of course, because negative times negative will give us positive. 2 2's will give us 4, so that's positive 4. But when we do the inner, we'll get negative 10x. The outer, we'll get negative 10x as well. The same signs are the same, so I don't keep the sign. That's negative 20x, which is what we're looking for in the middle, right? So it works out. Now, why we end up with a square up top for the other one? Well, if we multiply 5x minus 2 by itself, it's really the square of the quantity 5x minus 2. So either option is fine. And for the last one now, what's common in both terms? Remember, you're always supposed to look for it in every single case of factorization. 2 is common for sure. And so we're left with 9x squared minus 4. Right? If we look in the bracket, we cannot factorize using the highest common factor, but we know 2 is a factor. But this looks like a perfect square, meaning it's in the form of a squared minus b squared. And once we see that situation, it's going to be a plus b times a minus b. We call that the difference of 2 squares, right? Difference of 2 squares. So that's what we have here in bracket. It's actually, if you look at it, 9x squared can be written as what? 3x all squared. And the 4 can be written as 2 to be squared. So what we really have is 3x minus, or we can say plus 2, then 3x minus 2. Okay, so if I do it the longer way, I'm showing you this is actually 3x to be squared minus 2 to be squared. And once we have that situation, then we know it's a difference of 2 squares, so it's 3x plus 2, 3x minus 2. So these are the 3 factors. The 2 is a factor, the binomial 3x plus 2 is a factor, and the other binomial 3x minus 2 is another factor. And that